Okay, good day, everybody. Uh, can you guys indicate with a thumbs up if you can hear me? Am I audible? Sweet. Okay, that's brilliant. All right, thanks, guys. Thanks. Um, is the document up? Can you guys see it? Again, please indicate with the thumbs up. Okay, that's sweet. Right. I think we can. I see that we almost 5 minutes late. I wanted to give it a few minutes, wait for others to join. Let's just give it 2 minutes and see if there's anyone who's gonna come in. Otherwise, we will start from where we left off yesterday, just to try and quickly wrap up what we didn't cover, and then we'll start with what we're supposed to be doing today. Let's just give them 2 minutes, and then we will start. Yeah, I think we were here. All right, I think let's continue. They will find us on the way. Okay, we were on the exercise number 1. So we were asked to use the distributive law of multiplication over addition to expand the expression, the given expression, and we were asked to reduce it to, or to expand it to, one containing the sum of 4 terms. I think we have already established the 4 terms. 4 terms, each term being the product of 3 numbers. Okay, this is where we were. We wanted to get the 3 numbers of each term. Now you guys have established the 4 terms. I don't know if you can please rewrite those on the chat section for me. The 4 terms. What did we say the 4 terms were? And then we will continue talk about the 3 numbers. Where do we get them to be 3 numbers? Because I think we were at 2 numbers for each term of those 4. But if you have established the 3 numbers of each term, just write them for me, please. Rewrite the terms for me, the 4 terms for me. with the 3 numbers each of those terms. So we're going back to the chart section to write those terms. So we had already broken the brackets that are inside the outermost one. Remember that we had already broken the small brackets inside by multiplying by 6 in the first bracket and then multiplying by 3 in the second bracket. Now write the final terms for me, the 4 terms with 3 numbers each. Are you guys winning? Are you winning on your side? I remember when I adjourned yesterday, we had already established that okay, the only thing that was left was for us to establish where the third number comes from of the four terms. We had already established the four terms. And then we were only left with um, adding the fourth number on the the third number on the two numbered terms that we had already established. Sorry. Okay, so yesterday we have established the four terms with two numbers by breaking the innermost brackets. Okay, I just wrote the terms on the chart section. Okay, so obviously the first term would be 6 multiplied by 5 to get, we have 6 multiplied by 5. That is the first term. And then the second term, we'll get it when we multiply 6 by 4. 6 multiplied by 4. That is to break that bracket. And then the third term comes from the second bracket, from breaking the third bracket, the second bracket. So we have 3 multiplied by 2. Sorry, that isn't supposed to be 3. So inside the bracket was 2 plus 1. So we have 3 multiplied by 2. And then the last term will be 3 multiplied by 1. So that is the four terms. So we have 6 multiplied by 5 plus 6 multiplied by 4 plus 3 multiplied by 2 plus 3 multiplied by 1. That is our four terms. But the question says the four terms must have 3 numbers each. Each term must have 3 numbers. Now here we have established the two numbered terms. So I wanted you to write me where will the third number come from. What is the third number of all those terms? So the third number is common to all those terms. What is the third number? Look at the original expression and then write me those terms. Look at the original expression. The original expression is 7 multiplied by bracket 6 multiplied by bracket 5 plus 4 close bracket plus 3 multiplied by 2 plus 1. Now we have broken the inside brackets, but there's one bracket that we haven't broken yet. So I want you to break that bracket to get me the final terms that the question is asking. So now we have broken all the brackets that are inside. Now we can rewrite. So on the chat section, I've rewritten everything down, but I want you guys to write me the final step. Write me the expression with four terms with 3 numbers each. Come on, guys, try. Okay, I see someone has tried. Um, okay, but now, uh, if you look at the question, let's go back to that question. The question says, do not actually calculate the result, but you express, um, write the expression containing the sum of 4 terms. So each term will be the product of 3 numbers. So each term is going to have 3 numbers. It's going to be the product of 3 numbers. That is, 3 numbers will be multiplied in each term. So it means you don't have to calculate. Um, you don't have to determine what is 6 times 5 and what is 6 times 4. You can leave it as it is. I just want you to write the final expression. You don't have to calculate 6 times 5, 6 times 4, 3 times 2. You see. So if you take out, um, let me give you a big hint. So if you take out, you remove the 7 times that is outside the brackets. If you remove the 7 times, and then you are only left with 6 times 5 plus 6 times 4 plus 3 times 2 plus 3 times 1. So as that stands, 6 times 4 plus 6 times 4, 6 times 5 plus 6 times 4 plus 3 times 2 times 3 times 1. That now is an expression of 4 terms, where the first term is 6 times 5 plus 3 times 4, this is the second, 3 times 2, the third, and 3 times 1, the fourth. But now, each of those terms is a product of two numbers. Each of them is the product of two numbers. The question wants you to write I want you to write the final one where each of the terms is a product of three numbers. Okay, I'm gonna write the first term for you, and then I'll ask you to write the rest of the term. So I've written the first term for you in the chat section. I want you guys to write me the rest of the terms. Who can give me the second term? That is the first term. 7 times 6 times 5. Yes, brilliant. That is the second term. The first term and the second term. And then what is the third term? 7 times 3 times 2 is the third term, and the final term. Yes, that's brilliant. Now, each of those terms is a product of three numbers. We have 7 times 6 times 5. That is three numbers. And then we started by breaking the brackets that are inside. So that gave us two numbers. So we established those four terms by breaking the inside brackets. And then, but still it gave us two numbers for each. And now you had to determine the third number. The third number was outside of the bracket, of the outermost bracket, which was multiplying on the whole of those, of what was inside the bracket. So that was 7, multiplying on everything inside the bracket. So 7 is common in all of those terms. Okay. All right, which of the commutative associative laws are associated with the following expressions? Okay, I think you can determine that by yourselves. Can you take a screenshot of that, and then you can determine whether which of the commutative or associative laws associated with each of those. I want us to move. Let's proceed to variables. We're gonna look at the variables now. Okay, so if you want to explain to someone how to find the area of a rectangle, 4 centimeters by 3 centimeters, you can tell them to multiply 4 by 3. That is the area of a rectangle. However, if you're not given the specific values for the rectangle, you can call the length of the rectangle L, and the width W. Then you can say that the area is L times W. This will do for any value of L and W. So consider the rule for expressing one quantity as a percentage of another. So putting the first quantity on top of the second and multiplying by 100. So that is a mouthful. However, if the first number is denoted by X and the second number by Y, then the rule boils down to X divided by Y multiplied by 100. That is the rule for determining the percentage. So this will be true for any values of X and Y. This is a great strength of using letters or symbols to represent numbers. We are then able to write down rules, expressions, and so on that are completely general, so that to find the answer in a particular case, all we need to do is we just substitute our particular values or given values or whatever into the appropriate expression. Okay. The main purpose of using letters or symbols to represent numbers or quantities is that it enables us to express practical truths about the real world neatly, succinctly, and in more general terms than we could if we insisted on sticking to definite numbers all the time. So this is illustrated with the laws that we have discussed earlier. Consider the commutative law of addition. So that the sum of two numbers is unique. That is, it does not matter which number is placed first and which second. The result is the same. So we use letters A and B. This law can be rewritten as A plus B is the same as reversing the order and having B plus A. So these two will always give us the same result for any values of A and B. So the commutative law of addition will be A plus B is equal to B plus A. So A plus B is the same as B plus A. So commutative law of multiplication is the same, that the order is not important. So if you have A multiplied by B, you get the same result as B multiplied by A. So the associative law of addition, A plus B plus C is the same as A plus B plus C. So the associative law of multiplication, A multiplied by B multiplied by C is the same as A multiplied by B multiplied by C. So the distributive law of multiplication over addition is the same as A multiplied by B plus C is equal to A multiplied by B plus A multiplied by C. That is A multiplying on everything that is inside the bracket. A multiplied by B to get AB plus A multiplied by C to get AC. Okay, for other fundamental rules, which we dealt with in passing, were the following. The product of any number with 0 is 0. So if you multiply any number with 0, you get 0. So the product of any number with 1 is that number. So the sum of any number and its negative is 0. So you have the number being added to its negative, you get 0. So the product of any number and its inverse is 1. So in terms of letters or symbols, these are elegantly stated. The product of any number with 0 is 0. So that means A multiplied by 0 is equal to 0. So the product of any number with 1 is the number. Means A multiplied by 1 is equal to A. And the sum of any number and its negative inverse is 0, means A plus negative A is equal to 0. A plus negative A is equal to 0. Lastly, the product of any number and its inverse is 1. So, so A multiplied by A to the power 1, A to the power negative 1 is equal to A, or A divided by A is equal to 1. Again, we could have used any one of the letters A to Z to formulate these two laws. So you can use any variable from A to Z. So everyday life abounds with examples of variables. So an example is a firm's gross monthly sales vary from month to month, usually in number and value. So your telephone account or water and lights account is unlikely to be the same each amount. So we say they vary. Is the rainfall of the average maximum temperature from day to day. Even seemingly constant items such as your flat or house rent or your salary are adjusted periodically and therefore are variables. So a variable is something which can assume any one of the several numerical values. So the symbols most often used to represent variables are letters of alphabet, both uppercase, such as A, B, and C, and lowercase, such as X, Y, and Z. The symbol of letters which is used to represent is simply a label. Its specific value has to be assigned directly or determined by calculation in each relevant instance. Always choose a symbol that is short and the one that makes sense. Okay, I've got a quick activity or exercise for you guys. It should take about let's give it 5 minutes. We can give it 5 minutes. So determine the numerical value of the following expressions. So the first one is 12x plus 17. If x is equal to 2. And the second one is x squared minus 3 if x is equal to 4. Let's determine 2x squared if x is equal to 3. 4x minus 1 if x is equal to 5. X plus 7 divided by 3 if x is equal to 5. And also x plus 3 multiplied by x minus 2 if x is equal to 6. Let's get into it. Let's try this in 5 minutes. Okay, yes, the class is being recorded. The recording will be made available to them. The recording will be made available. All right, guys. I think let's move on. I see some of you have worked them out. So well done to those who got the answers correct. So I think take a screenshot and then you can work on them on your when you get time to finish them up. So what I'm going to do is unshare this document and then share another one. I want us to go and look at fractions. I'm going to unshare this one and share another document quickly. Can you guys see the document? Is it already up? Okay, now this is the document that has got fractions. Can you guys see it? Okay, sweet. I hope everyone can see it. I saw one thumbs up, but I'm hoping that it's visible to everyone. Okay, so we look at the division and multiplication of fractions. Okay, the fraction 10 over 2 means that 10 must be split into a number of groups of size 2 each. So the question is, what is the number of groups? The answer is 2 plus 2 plus 2 plus 2 plus 2 plus 2, which is equal to 10. So 5 groups of size 2 each added together will give us 10. In short, 10 divided by 2 is equal to 5. So what about 4 divided by 1 over 2? So in mathematical notation, this is 4 divided by 1 divided by 2, which is the same as 4 divided by 1 over 2, or 4 over 1 divided by 1 over 2. Okay, the 1 over 2 poses a problem. The 1 over 2 in the denominator is the one that poses a problem. Okay, you must find a way of getting rid of it. Maybe it could be changed to something that is easier to work with. So to make the 1 over 2 more manageable, we multiply it by 2 over 1. That is, we have 1 over 2 multiplied by 2 over 1 to get 2 over 2, which is equal to 1. So to multiply factors, we multiply the numerators by each other and the denominators by each other. The numerator is the top part of the fraction and the denominator is the bottom part of the fraction. So take the rule that whatever is done on the left-hand side of the equation, we will deal with that later. So whatever is done on the left-hand side of the equation also has to be done on the right-hand side of the equation. Then expand it to whatever is done to the top part of the fraction has to be done to the bottom part as well, so that the effect is cancelled. So that's 4 divided by 1 divided by 1 over 2 multiplied by 2 over 1 divided by 2 over 1 is equal to 4 times 2 divided by 1. So we have 4 divided by 1 multiplied by 2 divided by 1. So we have 4 multiplied by 2, and then we have 1, and then the denominator will have 1 multiplied by 1. So that is, we have 4 times 2 divided by 1 multiplied by 1, which is 1. Okay, all divided by 1 times 2 divided by 2 times 1. So we'll have 2 and 2 cancelling out. We'll have 1. So everything that divides on the 4 multiplied by 2 will reduce to 1. So note that 2 divided by 1 divided by 2 divided by 1 is equal to 1. That means we do not change our original problem. We multiply it by 1 in a manner that suits us. Okay, so now that we have the idea, let's find some shortcuts. Let's take the bottom part of the fraction and turn it around using divisions, brother. The multiplication sign as accomplice. You then get, let's say we have 4 divided by 1 over 2, which is equal to 4 divided by 1 over 2 is equal to 4 times 2 over 1, which is equal to 8. So if you look at what happened, the division changed into multiplication, and then when it changes to multiplication, whatever was on top, it becomes on the bottom. So we have 1 over 2 dividing on 4. So now we change to multiplication, and then 2 goes on top, and then 1 comes to the bottom. We have 4 multiplied by 2 over 1, which is equal to 8, which is exactly the same answer as the one we got before. Okay, let's try another one. We have 15 divided by 1 over 3. 15 divided by 1 over 3 is equal to 15 divided by 1, all divided by 1 over 3, multiplied by 3 divided by 1 divided by 3 over 1, which is equal to 15 times 3, we get 45. 1 times 1, we get 1 divided by 1 times 3 gives us 3, and then 3 times 1 is equal to 3. So 3 divided by 3 is 1. So we're left with 45 only. Or similarly, 15 divided by 1 over 3 is equal to 15 times 3 over 1, which is equal to 45. Then 15 can be rewritten as 15 over 1, and therefore 15 over 1 over 3 equal to 15 divided by 1 divided by 1 over 3, which is equal to 15 divided by 1 divided by 1 over 3, which is equal to 15 times 3 divided by 1 times 1 to get 45. Okay, so let us take a closer look. The 15 divided by 1 stays as it is, but the 1 over 3 changes to 3 over 1. So if we take 15 over 1 divided by 1 over 3 and attach it to the following letters, we can write down the answer immediately. So let's take that expression, 15 divided by 1 divided by 1 over 3. So we have T for top, and then U for under, and then we also have U for under, and then T for top. So that changes to 15 divided by 1, and then the 1 for under will stay on the underneath, and then 3 goes on top. We have 15 divided by 1 multiplied by 3 over 1. The following fraction should then not be so difficult. Let's take a closer look at it. 3 divided by 4 divided by 5 over 6. Okay, we have T, U, T, top, under, so the second T, sorry, should be under, so it should be T, under, T. So 3 over 4 divided by 5 over 6. So T, U, T. So it's top, under, top. So which is equal to 3 divided by 4. So the 4 is under, the 3 is top, multiplied by 5 is under the second fraction. So 5 will be under, and then 6 will be top. So so we said in multiplication of fractions, the numerators multiply each other, and then the denominators multiply each other. So we're going to have 3 times 6 and then 4 times 5 to get to the final answer. Or if we have 3 divided by 4 divided by 5 over 6, we immediately change that to multiplication, and then whatever on the second fraction, whatever was on top goes underneath, and then whatever was underneath goes on top. So we'll have 3, the first fraction stays as it is, 3 divided by 4 multiplied by 6 divided by 5. Can you see the pattern in the answers of the following fractions? So 10 divided by 200, 10 divided by 20, 10 divided by 2, and 10 divided by half, and then 10 divided by 120. Let's have a look at the pattern. The simplification gives 10 over 200 is 1 over 20. 10 over 20 is 1 over 2. So 10 over 2 is equal to 5. And 10 over 1 over 2 is equal to 20. And then 10 over 1 over 20 is equal to 200, from which we can reduce that 200 200 is bigger than 20, and 20 bigger than 5, and then 5 bigger than half, and then the half bigger than 120. Sorry, 1 over 20. So in simple terms, the smaller the denominator gets, the larger the answer becomes. So the smaller the denominator, that is the bottom number, the larger the answer we get. Think about it. If you split 10 into groups of 2, you get only 5. But if you split 10 into groups of half each, you get 2 groups for each unit. Therefore, for 10 units, you get 20 groups. Okay, since we are looking at division, what about dividing by 0? Look at the following pattern. So if we have 1 over 1, any number divided by itself gives us 1. So 1 over 1 gives us 1. So 1 divided by 1/10 or 1 over 10 will give us 10. And 1 divided by 1 over 100 will give us 100. And then 1 divided by 1 over 1000 gives us 1000. And then 1 divided by 1 over 10,000 gives us 10,000. We see that 1 is larger than 1 over 10, which is larger than 1 over 100, and so on. The smaller the number by which you divide, the larger the answer. So you know that 1 over 10,000 is smaller than 1 over 1,000. So the answer of 1 over 1 over 1,000 over 10,000 is going to be bigger than 1 over 1,000, because 1 over 10,000 is way smaller than 1 over 1,000. So the smaller the denominator, the bigger the answer. So the smaller the number by which you divide, the larger the answer. The closer the number by which you divide to 0, so the larger is your answer. But you can never divide by 0, because that answer has not been defined mathematically. So if you look at it differently, question: how many 2's do I have to add to get to 6? We know that 2 plus 2 plus 2 is equal to 6. So the answer, there will be 3 2's. Mathematically, it can be written as 6 divided by 2, which is equal to 3. Question: how many zeros do I have to add together to get 6? This cannot be determined. Written mathematically, 6 divided by 0, it has no meaning, or it is undefined. So the activity, can we calculate the following fractions? 12 divided by, what is 12 divided by 1 over 3? Number 2, 5 times 4 divided by 1 over 5. Can you guys quickly determine this division by fractions? Okay, yes, indeed. The correct answers are 36 and 100. So well done. I hope you guys are also getting the same answers. So 12 divided by 1 over 3 will give you 36, because you have 12 divided by 1 over 3, which is similar to 12 over 1 multiplied by 3 over 1. So it's 12 over 1 multiplied by 3 over 1. So we have the numerators multiplying each other. So we're going to have 12 multiplied by 3, and then 1 multiplied by 1, which is the same as 1. So that gives us an answer of 36. So similarly to number 2, we get 5 times 4, which gives you 20. 20 divided by 1 multiplied by 5 over 1. So you'll get 20 times 5, which is 100. Let's have a look. So simplifying gives the following: 12 divided by 1 multiplied by 36 over 1, which gives us 36. And then we have 5 times 2 divided by 1 over 5. So 5 times 4 divided by 1 over 5 is equal to 5 times 4 times 5, which is 20 multiplied by 5, which gives us 100. Okay. So let's look at addition and subtraction of fractions. How do we calculate 4 divided by 13 plus 2 divided by 5? The easy way to go about it is to use the calculator. But let us look at finding a method for solving such problems without using a calculator. So let's start with something easy and try to find a method. For example, 2, which is equal to 1. So it's half plus half, which gives us 1. What we actually did was to write a common denominator for the two denominators. This is of course 2. So the common denominator between the two denominators is 2. Then we fill in the numerator part. We have 2. You're taking the common denominator, which is 2, and then by asking how many 2's in 2, you will get 1. And then for the second numerator, by asking how many 2's in 2, you'll get 1, and then you multiply by 1 to get 1. So we have 1 plus 1, which is equal to 2 over 2, which gives us 1. Okay, so let's look at other fractions as well. So if we have 3 over 4 plus 1 over 4 plus 6 over 4, you see that there is a common denominator between the three fractions. The common denominator is 4. So you write that one down, and then you write it under the division sign, and then we go to the first fraction. You ask how many 4's in 4. That there will be 1, and then 1 times 3, that is the denominator, you get 3. And then go to the second fraction. How many 4's in 4? There will be 1. So what is 1 times 1? You get 1. So it's a plus 1. And then you go to the third fraction. How many 4's in 4? There is 1 4. And then what is 1 times 6? 1 times 6 is 6. And then you add the numerators. 3 plus 1 plus 4. 3 plus 1 plus 6. You get 10 divided by 4. So the answer is 10 divided by 4. But the 2 is common in between the two, the numerator and the denominator. You can divide by 2 both of those. There'll be 5 2's in 10, and there'll be 2 2's in 4. So to get 5 over 2. Okay, so if we add fractions and they all have the same denominator, it is quite easy to do the sum. What about a case where they are different? 4 divided by 13 plus 2 divided by 5. A solution is to find the same denominator for both. The easiest way is to multiply the sum. Okay, multiply the two denominators. So if you multiply the two denominators, what do you get? You get 65. But 4 divided by 13 is not 4 divided by 65. So if we multiply the 13 by 5, we must multiply the 4 by 5 before we add. So we have 4 divided by 13. I'm sorry. This should be 13. Okay. So which is going to be equal to, we're multiplying by 5 in the numerator and denominator. So 4 times 5 divided by 13 times 5. So we get 20 over 65. And if we go to the second fraction, we have 2 divided by 5, which is equal to 2 times 13 divided by 5 times 13. So it's equal to 26 divided by 65. So now these two fractions have the same denominator of 65. So we've converted them to have the same denominator of 65. So we can now add them. So 4 over 13 plus 2 over 5 is equal to 20 plus 26 over 65, which is equal to 46 over 65. So the shortcut would be 4 times 5 plus 2 times 13. So you can just, you take the product of the two denominators, which is 65, and then you can cross multiply. That means the 4 of the second, the 4 is going to be multiplied by the denominator of the second fraction. That is going to have 4 multiplied by 5, and then the 13 is going to multiply the numerator of the second fraction as well. So you have 2 multiplied by 13, and then we have 4 times 5 plus 2 times 13 divided by 65. And then you just proceed with the operations. 20 plus 26 over 65. Okay, let's look at the activity that is given. Calculate the answers for the following. We have 3 over 4 minus 1 over 2. So we have different denominators. So we have to make them have the common denominator. Make them have the same denominator. Okay, let's see. Simplifying gives 3 over 4 minus 1 over 2 is equal to 3 minus 1 multiplied by 2. 1 multiplied by 2. So we take the common denominator as 4. And then how many 4s in 4? There's 1. 1 times 3 is equal to 3. And then 2's in 4, there's 2 multiplied by 1, which is 2. So 3 minus 2 is equal to 1. So the answer is 1 over 4. Okay, I want to look at you to look at the third one. The third option, which is the simplest. We have 3 over 4 minus 1 times 2 over 4. So we just make the denominators the same. So we have 1 over 2 So if you multiply the numerator by 2 and the denominator by 2 of the second fraction, it will make things easier. You will have 2 on the numerator and then you have 4 on the denominator as well. So it's going to be 2 over 4. So 3 over 4 minus 2 over 4. So you take the common denominator as 4. So we have 3 minus 2 in the numerator part, which gives you 1 over 2. So number 2 was simplify 17 over 23 plus 2 over 1, or just 2. Okay, so we have 17. So the common denominator is 23. Of the 2, we have 17 over 23 plus 2 over 1. So the common denominator will be 23. It will be 23, and then how many 23s in 23? There's 1 multiplied by 17, it's 17. And then plus how many ones in 23? There's 23. 23 times 2. And then you add, you get 63 over 23, which is 217 over 23. Okay, so simplifying gives, what is the third one? Okay, the first thing would be to convert the mixed fraction into the improper fraction. You say 4 times 3 plus 1. 4 times 3 plus 1 gives you 13 divided by 4. You're keeping the denominator. That's how you convert from a mixed fraction to an improper fraction. So you multiply the denominator by the whole number and then you add the numerator. But you keep the denominator the same. So 4 times 3 plus 1 is equal to 13 divided by 4 minus 9 over 10. And then you make these have the same denominator. So we can multiply by 10 of the first fraction, 10 on the top and 10 on at the bottom. So we have 10 times 13 divided by 10 times 4. And then that means you're going to have to multiply by 4 over 4 on the second one, so that they will have both have the denominator of 40. And then you can proceed with your, okay, 40 is in 40, there'll be 1, and then multiplied by 130. And then 40 is in 40, there'll be 1 multiplied by 9 times 4. You proceed with your operations. All right, okay, let's continue. Let me select a few for you guys. We have 12 divided by 1 over 5. No, not those. Okay, I think you guys have done those. Number 1 and number 2. Okay, let's not do number 1 and number 2. But can you guys start at number 3? Determine the value of the fractions number 3 up to number 5. Number 3 up to number 5. Okay, of course, we can label them. This one is gonna be top. Okay, we have under, and that's top. So this is now when you change it to multiplication. So the 8 remains top, 13 is under, and then in the second fraction, 12 now becomes under, and then 25 becomes top. Okay, in number 4, the first thing is to convert the mixed number or the mixed fraction into an improper fraction. All right, guys, let me share my workings with you. Okay. Okay. That is listed in number 3, basically. So 8 divided by 3 divided by 12 divided by 25. So okay, we have T U U T. Okay, so 8 on top, 13 on the bottom, and then 12 on the bottom, and then 25 on top. So 8 divided by 13 multiplied by 25 over 12, which gives us 200 divided by 156, which is equal to 50 divided by 39, or 111 over 39. Okay, number 4, simplifying gives 8 quarters, or 8 1/4 divided by 1/2 becomes 8 times 4, which is 32 plus 1, 33, then divided by 4, that is the first fraction, multiplied by 2 over 1. So which is equal to 66 divided by 4. We get 33 divided by 2, which is equal to 16 halves. Okay, number 5, simplifying will give 17 over 20 plus 1 over 4 minus 3 over 5, which is equal to, okay, the lowest common denominator will be 20. Okay, how many 20s in 20? There's 1 times 17, so it's equal to 17. And then how many 4s in 20? There's 5. Then what is 5 times 1, or 1 times 5? And then how many 5s in 20? There's 4. So 3 times 4. So we have 17 plus 1 times 5 minus 3 times 4 over 20, which gives us 5 over 10, which is equal to 1 over 2. 17 plus 5, which is 22, minus 12. Am I right? Seventeen plus 5 is 22, minus 12, which gives me 10. Okay, and then 10 divided by 20 is the same as 5 over 10, which gives me half. Okay, so the final answer is 1 over 2 for the second one. Okay, powers and roots will be done. I think we will start the powers and roots sometime next week. We'll start powers and roots maybe Saturday next week. Okay, I'm looking at, I'm gonna stop sharing this document and then share a question paper from the previous years. There's just two problems from what we've covered so far that I've identified on this question paper. Okay, can you guys see the question paper? Is it up? Okay. All right. Have a look at number 4. Okay, remember what we did, what we were doing yesterday. About the priorities. Okay, number 4 says the expression 24 minus 4 times 2 plus 6 plus 2 times, open bracket, 4 plus 2 to the power 3 minus 4 minus 1, close bracket, can be rewritten as number 1, 12 plus 6 plus 2 times 5. Number 2, 12 plus 6 plus 2 times 2. Number 3 is 3 plus 6 plus 2 times 5. Number 4, 12 plus 8 multiplied by 4, or none of the above. Can you guys, using the priority rules that we discussed yesterday, and I think we did today as well, the priority rules, can you determine which of these 4, okay, even option number 5, which of these best describes that expression? Apply the priority rules to simplify the expression. So one of those describes the simplified version of that expression. So it's 24 minus 4 times 2 plus 6 plus 2 times 4 plus 3 to the power 2 minus 4 minus 1. Obviously, the chart that we showed yesterday was that the change sign is on the top, at the top of the chart. That is, takes high priority, but that does not apply on this one. And then next, second highest priority was the all forms of exponentiation. If you see exponentiation, you deal with it first, and then after that, okay, so you deal with multiplication and division if they are in the expression, and then comes addition and subtraction at the lowest level of the priorities. So basically, the first thing is to go to inside the bracket. You simplify everything that is in the bracket there. And then let's see what you get. And then you will deal with multiplication and your division. All right, guys. Are you getting anything that is close to the options that are given? So we have 24 minus 4 times 2 plus 6 plus 2 times 4 plus 2 to the power 3 minus 4 minus 1. So the first thing that we do, because we started the bracket, the exponentiation of 2 to the power 3, which becomes 8, and then 4 and minus 4 cancels out. So in the bracket, you would be left with 2 to the power 3 minus 1, which is 8 minus 1, which is 7. So that means the last part of that expression, you have 2 multiplied by 7. So you have 2 multiplied by 7. And then let's go to the first part and just apply the priority rules. We have 24 minus 4 times 2 plus 6 plus 2 times 7. Now we have dealt with the bracket and we have reduced it to 7. So 24 minus 4 times, okay, by the looks of things, now we have to deal with the multiplication. We will leave the first operation of minus sign. Then we deal with the multiplication. 4 times 2, which is 8. And now we get 24 minus 8 plus 6 plus 2 times 7. So this is because we see that in all the expressions, the last part has got a multiplication. So it's got a 2 multiplied by something something. So we don't have to determine that. So we leave it as 2 multiplied by our 7. And then 24 minus 8 gives us 16. We get 16 plus 6 plus 2 times 7. So now after that you can reduce, you can conclude that none of these best describes the simplified version of that expression. So if you apply the priority rules, so your first entry of the reduced expression should be 16, because 24 minus 8 is 16, plus 6 plus 2 times the last part, which comes from the bracket. The bracket reduces to 7, and none of those have a 7 as the last entry of the expression. So we can conclude that none of the above describes that expression. Number 2 involves the fractions that we did today. But because we have run out of time, I would like you guys to take this, just take a screenshot of it and then try and practice it and see what you can get. We have 3 over 4 plus 1, 9 over 12 plus 2, 1 over 7. So obviously it involves the conversion of these mixed fractions into improper fractions, and then you you can apply your priority rules by starting at the multiplication and then add your fractions. Just take a screenshot of it and then you will practice. Maybe the first thing next week we're gonna have a look at it. I will share with you my answer as well. Okay, otherwise I think we are done for today, guys. We almost towards 10 minutes past 2. We were supposed to finish at 2. So thank you for making the time, and I will see you guys on Friday next week. Have a nice day. Thanks, guys. Bye.